Fractions, equivalent fractions. Take any three similar sheets of paper and shade a half of it in this way. The first one we will divide it into two parts using a vertical line like this. The second one we will divide it into four equal parts and the last one into six equal parts. Now, from the first figure, we can write that the shaded part is 1 out of the two pieces. So, we will represent this as 1 upon 2. In the second figure, shaded part is represented by 2 pieces out of 4. So, that is 2 upon 4. And in the last figure, 3 pieces out of 6 were shaded. So, this is 3 upon 6. But the initial paper we have taken is same in all cases, which means the shaded part in all the cases is same. So all these fractions we have written will represent a same shade of the paper. So these fractions are equivalent. They are representing the same thing. First thing is 1 upon 2, and for that 2 upon 4 is also same, and 3 upon 6 is also same. So these fractions will be equivalent. Now consider 2 upon 3. This is a fraction. How to write equivalent fractions for this particular fraction? For that, we can multiply both numerator and denominator by same number. Then whatever we get, those are equivalent. Consider the same fraction here 2 upon 3. Initially, we will multiply both numerator and denominator with 2, then with 3, 4, 5, and 6, so on. On doing this multiplication, the first one would be 4 upon 6, and then 6 upon 9, 8 upon 12, 10 upon 15, 12 upon 18. All these fractions we have obtained them from the same fraction, that is 2 upon 3. So these are equivalent to 2 upon 3. And the equivalent fractions can also be obtained by dividing both numerator and denominator with same number. Consider this particular 24 upon 32. This 24 will have some factors. The factors are listed here. Then even 32 will have some factors. Of these, if we see, there are some common factors here like 2, 4, 8. These two are common for both numerator and denominator. So when we divide them with these numbers, the fraction so obtained will be equivalent. Say let us initially we will divide it with 2, then with 4, and then finally with 8. The first one gives 12 upon 16, then 6 upon 8, and finally 3 upon 4. So for 24 upon 32, all these three are equivalent fractions. There is a fact regarding the equivalent fractions. That is, whenever we take any fraction and its equivalents like this, and consider any two of these now. I am taking 6 upon 8 and 3 upon 4. When we multiply the numerator of one fraction with the denominator of second fraction, it will be equal to the product of denominator of first fraction and numerator of second fraction. In this case, we have 6 into 4 is 24, and denominator of first one is 8. 8 into 3, the numerator of second fraction, it is also 24. Both are same. Take another set of equivalents from this, that is 24 upon 32 and 3 upon 4. In this case also, if we find the product, we call this as cross product also. That is product of numerator from first factor with denominator of second factor will be equal to product of denominator from first factor and numerator from second factor. Now, in this case also, the product in both the cases is 96, which means they are equal. So, in this way, you can verify your equivalent fractions. Now, we'll see few problems for equivalent fractions. We may get a problem like this. We already know that first one is 2 upon 9, and here we don't know the value upon 63. Now, if we see, the value has got increased, which means we have to multiply it with some number. We'll see in ninth table when can we get 63. 9 sevens are 63. So even the numerator we have to multiply this with the same number. So 2 into 7, that is 14. Here the value would be 14. Consider another example. 15 upon 35 equal to, we don't know the upper value, upon 7. Now the value has got decreased, which means it was divided by a particular number. See in seventh table when can we get 35? That is 7 fives are 35. So we have to divide this number with 5, then we will get 7. So with the same number we will divide the numerator also. Then here we will get 3 as the answer. So the value here would be 3. We will look into few other questions in this manner. Consider 2 upon 7 equal to 8 upon the value we don't know here. Now the value has got increased, which means we have multiplied this with some value and that gives this. So 2 times 4 is 8. So with the same number we have to multiply the denominator as well. In that case we will get here 7 into 4 is 28. So in this blank we can write 28. We'll take another example. 5 upon 8 is equal to 10 upon, we don't know this value. So again it has got incremented, which means we have to multiply. By what number? We know that 5 twos are 10. So it is into 2. So even the denominator we have to multiply with 2. 8 twos are 16. Say another example, 3 upon 5 equal to, the numerator we don't know, in denominator we have 20. Now the value has got increased, which means we have to multiply some number. We know that 5 into 4 gives 20. So even numerator we have to do the same thing, that is into 4. 3 into 4 gives 12. Now let us take 45 upon 60 equal to 15 upon, don't know what's the denominator here. Now what's the relation here? The value has got decreased, which means we have to divide this. So in 15th table, when can we get 45? It is 3 times. So we are dividing this number with 3 and that gives 15. In similar way, even 60, we have to divide this with 3. 60 divided by 3 gives 20. So here the denominator is 20. Consider another example, 18 upon 24 equal to, numerator we have to find and in denominator we have 4. Now again check, the value has got decreased, which means we have to divide. In fourth table when can we get 24? It is 4 times 6. So 24 was divided by 6 to get 4. In the similar way even we have to divide 18 with 6 and we'll write the answer 3 here. Now let us check few other questions. We have to see whether the given fractions are equivalent or not. Consider this, 5 upon 9 and 30 upon 54. Now tell whether these two are equivalent or not. We'll check both the numerator and denominator. The value has got increased, which means we have multiplied this. And 5, when can we get that? It is 5 times 6 is 30. And even denominator, if you see, 9 times 6 is 54. Both numerator and denominator were multiplied by the same number, which means they are equivalent. So both the fractions are equivalent. We'll take another example. Say 3 upon 10 and 12 upon 50. Now, if we see this, the value has got increased, means we are doing multiplication. In 3 table, 3 times 4 gives 12. And for the denominator, it's 50. So 10 into 5 gives 50. Numerator, we are multiplying 4, but in denominator with 5, which means these are not equivalent. The numbers have to be same. Consider another example now. 7 upon 13 and 5 upon 11. Here both the numerators are prime numbers and even the denominators are prime. So they are not equivalent. They can't be equivalent. Simplest form of fractions. A fraction is said to be in the simplest form if its numerator and denominator have no common factor except 1. Consider this fraction 2 upon 9. Factors for numerator are 1 and 2 and for denominator 1, 3 and 9. In these, we have only 1 as a common factor. So we can tell this fraction is in its simplest form. Now consider another fraction 36 upon 54. First, list the factors for the numerator, and here is the list, and for denominator also. And if we check, there are so many common factors like 1, 2, 3, 6, 9, and 18. So this is not in simplest form. To convert this fraction into simplest form, now consider the highest common factor, that is 18 here, and divide both numerator and denominator with this number. When we divide 36 by 18, we'll get 2 and 54 by 18 gives 3. 2 upon 3 is the simplest form for 36 upon 54. Let us take another example, 48 upon 60. To find the HCF, we can use the long division method. Now in 2 times, take again 2 times. Now 3 times we can take 4 and 5. 4 and 5, for these two numbers we don't have any common factor, so we'll leave here. To find the HCF, we have to multiply all these numbers, that is 2 into 2 into 3. That gives the HCF for these two numbers 12. Divide both numerator and denominator with 12, and that gives the simplest form of the fraction. 4 upon 5 is simplest form here. Now we'll see how to find simplest forms for few other numbers. Let us take 15 upon 75. The first thing is to find the HCF. For that we will use the long division method. Here both the numbers are ending with 5, so I'm using fifth table here 3 times, and then we have 15. Again, we can use third table 1 and 5. So HCF would be the product of these two numbers, that is 15. Now when we divide both numerator and denominator with 15 here, and we can write the simplest form to be 1 upon 5. Consider any other number, say 17 upon 51. Again, if we take 17 and 51, 17 is a prime number, but we know that 17 threes are 51. So here 17 would be the HCF. When we divide both the numerator and denominator, we will get 1 upon 3 as the simplest form. Now consider another example, 42 upon 28. Again, HCF using long division method. Take the two numbers, both are even, so we'll start with 2, 21, comma 14. Now we can see that these two numbers can be obtained in the seventh table. So 3 comma 2. These two are prime. So we can't further use this division process. We'll stop it here, and HCF would be the product of these two numbers, that is 14. Divide both numerator and denominator with 14, and that would give the simplest form. The numerator is for 3 times and denominator 2 times, so 3 upon 2 gives the simplest form. And we'll try to complete this problem, that is to match column A with column B, and here we have to simplify and then only we can match. Check the first question, that is 250 upon 400. Now, as both numbers are ending with 0, we can divide with 10. That makes 25 upon 40. This is 5 and 0, so we can use fifth table. And in fifth table, 5 times and 8 times. So for this, 5 upon 8 would be the simplest form, and we have it here, D. And coming to the next one, that is 180 upon 200. Again, both the numbers are ending with 0, so we'll divide with 10. Now these two numbers we can use the second table as they are even. It comes out to be 9 upon 10. So for this second one, 9 upon 10 is the simplest form. And then consider this 660 by 990. Both the numbers are ending with 0. So when we divide with 10, it will become 66 upon 99. Digits are repeating, so we will use the 11th table. 11th table, if we divide this, it will become 6 upon 9. And these two we can further simplify using the third table. Divide both the numbers with 3, and that gives 2 upon 3. So for this fraction, the simplest form is 2 upon 3. So this would be the answer. Next question, 180 upon 360. Again, on dividing with 10, we'll get this. Now here, we can use the second table. Divide both numerator and denominator with 2. That gives 9 upon 18, and we know that 9 twos are 18, so it is 1 upon 2. The answer is 1 upon 2. Now for the fifth one, it's obviously this 2 upon 5, but we'll still look into that. It is 220 upon 550 in 10 table, 22 upon 55. Again, use the 11th table to divide, and we'll get 2 upon 5 as the answer.